Hello guys, this is another question that I want to share with you guys. So the question is that x is uniform in the interval -1 to 1. So we want to find gx such that if y equals to gx, the density function of y will equals to e to the power -y times the unit step function of y. So firstly, we can consider that the distribution function of y is uniformly distributed in the interval 0 to 1. So we can know that 0 is smaller than distribution function of y and smaller than 1. So after we get this inequality, we can times 2 into this inequality and get 0 is smaller than 2 times the distribution function of y and smaller than 2, and then we minus 1 to the both sides, and we will get -1 is smaller than 2 times the distribution function of y minus 1 and smaller than 1. So this equation is uniformly distributed in the interval -1 to 1. So we will just assume that x equals to 2 times the distribution function of y minus 1. So since we know the density function of fy, since we know the density function of y is equals to e to the power -y times unit step function of y, we can use the formula that the distribution function of y is equals to the integral 0 to y, and the inside is the density function of fy dy. So this is equals to 0 to y e to the power -y dy, and this is equals to negative e to the power -y, y 0, and is equals to 1 minus e to the power -y. So now we just let x equals to 2 times the distribution function of y minus 1, as we assumed above, which is equals to 2 times 1 minus e to the power -y minus 1. So x plus 1 divided by x plus 1 over 2 is equals to 1 minus e to the power -y. So e to the power -y is equals to 1 minus x plus 1 over 2, which is equals to 2 divided by 1 minus x. So now we just took the log on both sides. Log e to the power -y is equals to log 2 divided by 1 minus x, and this is equals to -y, equals to 2 divided by 1 minus x. So y is equals to 1 minus x over 2 times negative. So this is equals to gx. So we are done.